Hello guys, welcome to the chemistry revision where we are continuing with revision on the organic chemistry. So we'll continue revising organic chemistry. Probably this would be the last one. Okay, so it will be a long so it is going to be a long video because there are a lot of questions that I covered in this video. Okay, so we have this question which came in a certain exam in a certain year. So this was question 9, which says table. The table below shows some information on two polymers. The table below shows some information on polymers. Name of polymer, we have been told. So this table contains some information on what? On polymers. That's what they're saying. So we have the name of polymer in this part, its formula, then its type of polymerization. Okay, so that is what we have here. So now they've given us already, we have polyvinyl chloride, and they've said the formula is this one. Actually, they twisted the formula here, and then they're asking you to give the name of type of polymer it is. Then here, name of the polymer, they've hidden it. The name of the polymer, they've hidden it here. And then they've given you just the formula. Then here, they're asking you to say, okay, this formula, what will be the type of polymer is this one here. Okay. So now here, we are going to, okay, so now our job is to ensure that we identify the type of polymer. So this one, polyvinyl chloride, is a polymer of an alkene. Okay, now this is an alkene which has got actually an halide in it like chlorine here. So this one, I said they just had to hide it because it was supposed to be like in this. From what I know, it's supposed to be like in two carbons, one, two like this. Then there's a bond here, a bond here, a bond here. Then 1, 2, 3, 4. So now you have seen there's 3 hydrogen. It means you put one hydrogen here, one hydrogen here. Then you can put a chlorine here and another hydrogen here. This is how we write. This is the kind of formula I know. Now they like twisting these things, these guys. So they just decided to write C2. They decided to write this C. They write them just as C2. Then they decide to write this H3. 1, 2, 3. They say H3. Then they get a bond there. They put this one there. This bond here, they put it there. Like that. Then this there. Then this there. Then they put like that. N. N meaning repeating unit. So that's how they kind of twisted it. So this type of a polymer, it is an addition polymer. Okay, the type of polymerization which is made by joining similar units. When similar units are joined to form a long chain, the type of polymerization is addition polymerization, and the polymer is addition polymer. Then when we come to this one here, this one is a macromolecule. So a macromolecule, you can identify with a link here. When you look at this link looks like an Easter link. Okay, so that link looks like an Easter link. So if it is an Easter link, Then this macromolecule here should be pteridine. Okay, so this one is pteridine, and the type of polymerization which pteridine undergo, or type of polymer which pteridine is actually a condensation polymer. It's a condensation polymer. So that is the answer, because A said complete the table and we have completed. Then B, they're saying, what is the best method of disposing of polyvinyl chloride and polymer B? So they're saying, what could be the best method of disposing this one and this one here? Disposing meaning that if you are no longer using it, the way we throw rubbish, how can you best throw these as rubbish when you don't need them? That's disposing them off. So we are saying recycling is the best way. So you just recycle them. Then you see, name the products of protein hydrolysis. Protein hydrolysis is the process of breaking down protein. Now, protein are made from amino acids. Different type of amino acids joined together form proteins. Now, hydrolysis is the breaking down using water. So protein being broken down using water, they will go back to amino acids from which they are made from. So when they say name the products of protein hydrolysis, it is just amino acids where they came from. Then this is another question from, I think, the same year, section C. Study the following sequence of reactions. Glucose goes to ethanol, ethanol goes to ethene, ethene goes to polyethylene. Then they're saying A, Roman numeral 1, what name is given to the process by which glucose changes into ethanol? What name is given to the process in which, or by which, glucose changes to ethanol? Then Roman numeral 2, name the enzymes responsible for the change in A1 above. So you name the enzymes responsible for the change of glucose to ethanol above. What gas is produced during this process? So you name the gas produced during this process. Okay. I don't think I answered this one. Then B, name the process and the catalyst used when ethene changes into polyethylene. When this ethene changes into polyethylene, name the process and the catalyst. What catalyst is used here? So you name the process of changing ethene to polyethylene and also the catalyst used. Then you see, draw the structure of polyethylene with 3 repeating units. Like this structure formed here, you do what? You draw with 3 repeating units. Then in D, when polyethylene is bent in excess air, 2 products are formed. Name the products. When polyethylene is bent in excess air, 2 products are formed. Name the products. Then E, polyethylene is a non-biodegradable substance. Explain what is meant by the term non-biodegradable and state the effect of such polymers on the environment. So we'll start answering right away. Okay. So we'll start by A, Roman numeral 1. What name is given to the process by which glucose changes into ethanol? So what name is given to the process in which or by which glucose changes into ethanol? So that name is fermentation. Fermentation. So the process by which glucose is changed to ethanol is fermentation. So now we go to the next one, Roman numeral 2, which says name the enzyme responsible for the change in Roman numeral 1 above. What gas is produced during this process? So the change is The enzyme is zymes from yeast, and then the gas, I didn't name it. I didn't see this other part of the question. So the gas is carbon dioxide, which is produced during this reaction. So let me write the gas carbon dioxide. So the enzyme is zymes from yeast, and then the gas is carbon dioxide. Then we move to C. C is saying, B saying name. Oh, it's the one we have answered. Oh, name the process and the catalyst used when ethene changes into polythene. We name the process and the catalyst used when ethene changes to polyethylene. So let's answer. So now we are answering B. So the process by which ethene changes into polythene is addition polymerization. Then the catalyst is just a mixture. The catalyst for the reaction is usually a mixture of titanium and aluminum compounds. Okay. Then C, they're saying draw the structure of polythene with 3 repeating units. So I didn't understand properly. I thought they were talking of a monomer. So I answered here, but now I understand what they're saying. They're saying draw the structure of polythene with 3 repeating units. So it will just be like this. Polythene means we are using 3 carbon. So ethene, essentially ethene can be like this. See, a double bond like this, because polythene here, this one polythene, this one polythene here comes from joining ethene to form a polymer called polythene. So this one will have just how many carbon? Hydrogen 2, like this. This one will have only 1 hydrogen. This one will have 3. Now, so I've managed to come up with that because each carbon must be surrounded by 4 bonds. 1, 2, 3, 4. This one, 1, 2, 3, 4. This one, 1, 2, 3, 4. So, however, this polythene sometimes is written like this. These guys, they like writing it like C. They would rather write it like this. C. Let me just change it first. Let me try to shift the bond like C, like here. Okay, yeah. So it's the same. What I'm trying to do is just the same. Even if I shift the bond, it will be the same. So these guys, what they like doing, this part here, this one here, they 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 write it like this. So let me just start with this part. Let me just swap it like I start with C, then another C, then I put a double bond here. I'm just swapping so that I have 1, 2, 3. I want to show you how these guys like putting this. So here will just be 1, here will be 2. So this is ethene. So what they will do to make it, sometimes they can just write like this. I'm just changing it. They'll write this C and this one. They'll write the two of them. 1, 2, and put a double bond here. Then this one going here, they'll just put it like that, and they'll put a C, this C here. Then H, this H1, 2, 3, they'll just put like that and put a 3 there. Then they forget. Then you have seen this is this. Then this hydrogen here, they'll drop it here. Then these two hydrogen, 1, 2, they'll put them here. So that is how this can be written in either like this, the way it is, or like this. So, but them, they like putting it in this one, which a lot of people get confused when they see. So now it is the same one. Now we are using this one to write what they were asking Papa. Draw the structure of polythene with 3 repeating units. Units meaning we should have these repeating. This is 1 unit. Now we make them 3. So let me now answer it from here, because here there is already a wrong answer. So okay, sorry, okay. So now we will repeat this. Now, for a polymer to be formed, the double bonds must be broken. So these bonds will be broken. So there will be these 3 of them. So right. So for them to be 3, we'll have 6. So right. 1, 2, 3, 4, 5, 6. So I've repeated these. There are 6 of them. Now, instead of having double bond here, there will be single. So I'll put a single. So 3 units. So now I will just be, because this bond can go here, you break one bond here, comes here, comes here. So this is here and here. Then you put the hydrogen, these other things on everyone. So here, hydrogen 1, hydrogen 1. So here you're putting CH3. Here hydrogen 1. Here again you put CH3, hydrogen 1. Then here hydrogen, here hydrogen. Then you shift again CH3, hydrogen 1, then hydrogen 1 like that. So meaning this is the answer. So this is the answer just like this. So we have made 3 repeating units. This one, I'm just showing you. Don't answer it by putting those. You've seen these which are repeating. There are how many? There are 3. 1, 2, 3. You don't put these lines up. Put them to show you that they are repeating units. That's what they mean. So these were not the answer. These were the monomers. So they are wrong. So we move to the next question. So the next question says, see, D. When polythene is bent in air, let me push. When polythene is bent in air, in excess air, 2 products are formed. Name the products. So the same one, the polymer polythene, when it is bent in air, in excess air, what are the 2 products? So the 2 products are 1, carbon dioxide and water. Then E, polythene is a non-biodegradable substance. Polythene is a non-biodegradable substance. Explain what is meant by the term non-biodegradable and state the effect of such polymers on the environment. So first of all, we explain what is meant by the term non-biodegradable and also state the effect of such polymers on the environment. So this is a polymer, it is non-biodegradable. We explain what is meant by the term non-biodegradable and also state the effect of these polymers not being biodegradable or by being non-biodegradable. So in answering, we say it means it cannot be broken down into simpler and harmless materials by microorganisms. Yes, if something is non-biodegradable, it means it cannot be broken down into simpler and harmless materials by microorganisms, meaning it doesn't rot like plastics, are polymers, are polythene. So those don't rot, so they are non-biodegradable. Now, let's state the effect of such polymers on the environment. So we are saying such polymers accumulate in the environment, causing litter. It causes litter, landfill, meaning it consumes those spaces where people dig uh, and dump them there. And wildlife hazard, it is hazard to wildlife. Animals, when they eat these, they die. So in short, they are pollutant. So we move to another question 19, came from section A in a certain paper, like a pupil reacted the monomers shown below. There is this monomer and this monomer. So when you look at this from the other revision, this is a diamide and this is a dicarboxylic acid. Looking at the ends here, we have an amino group here and here. Here we have a carboxyl group here, COOH here. So this one is a dicarboxylic, meaning there are two these. This is a diamine because there are two amine here. Now they're saying what name is given to the product of the reaction between the two monomers above. These guys too, when they react, they give us nylon. Remember nylon. So the answer is A. Then we come to 20, A20. Below are some structures of organic compounds. Which organic compound will react with rubidium? So, rubidium is a metal. So, metals react with acids. So, only an organic acid would react with it. So, when we check here, an organic acid structure, organic compound would be an organic acid. And an organic acid should have a functional group, something like COOH at the end. So this one doesn't have COOH. This one doesn't have. This one has. You have seen COOH. So meaning the answer is this one. Which organic compound will react with rubidium? It is this one here, which is 4. So the answer is A. We come to B6. B6 says below are chemical formulae of organic compounds. These are chemical formula of organic compounds. We have this one, C2H4, CH3OH, CH3C, CH2CO2H, then HCO2H, C2H6, CH3CO, CH2OH. These ones here. Then they're saying, A, name the compound which reacts with steam. So, a compound which reacts with steam mostly should be an alkene. So, when we check here, which one should be an alkene? Remember, alkene have got a general formula of CnH2n. So if they have, and they only have, they start with carbon n is equal to 2. N is equal to 2 because of the double bond. You can never start with n is equal to 1. So if we put n is equal to 2, I just want to see if I can identify an alkene here using this formula. So I'll start with n is equal to 2 because to start counting or to start or molecules of alkenes, they start with 2 carbon atoms. So n is equal to 2 carbon atoms. I'll say C, I'll put where there's N2, H, here I'll put 2, then times where there's N, I'll put 2. So this one will be C2 the way it is, then H, 2 times 2, 4. So I'll have this one is the first family. So the first family of the alkene starts with N is equal to 2. So this one is ethene. Okay. So now ethene, I'll check here. Do I have ethene? Yes. So if the question says name the compound which reacts with steam, alkenes reacts with steam, and for this one it is that one there. So say ethene, which is C2H4. Then B, draw the structural formula of a compound which turns blue litmus paper red. So draw the structural formula of a compound which turns blue litmus paper red. So a compound which turns blue litmus paper red, it is an acid. So meaning they want us to identify an organic acid. And remember what I said, that an organic acid should have COOH. So in your identification, your target is to ensure that you find one which has COOH. Okay, let me just clear everything here. Seems to be having issues clearing everything here. Okay, so now we are saying when we look at this one, I think this one should be an ester. This one have COOH, right? This one an ester, I think. COOH. This one seems to have, this one doesn't. So there's this one also seems to have, except that we can also look for a formula. Let me see if I did that one. Okay, I had just to put this one as an answer, but before putting an answer there, carboxylic has have a general formula like CN minus 1, then H2N also should be minus 1 COOH. So if you cannot identify the carboxylic acid from here, you can begin by using this formula by saying, okay, let me start with the first member, N is equal to 1, and replace if you have it here. So say, okay, if you say C, where there's N, you put 1 minus 1, then you say H2 times, where there's N, you put 1 minus 1, and you say COOH. Okay, so here you have C, 1 minus 1 is 0, then here H, 2 times 1, 2 minus 1, 1, then here COOH. Then this, because it has a 0, it will disappear. This one has a 1, it will just be C. Then you can write it as C, then these two O. We can write them like O, O, H. Qualifies, huh? So this one, when I look at what I have, this one qualifies. Now, I don't know for this one if it can qualify. This one also if it can qualify. But since this one has qualified, let me see what I had to put here. I had to put this one 1, 2, 3. Let's see. Which one did I use? 1, 2, 3. Carbon 1, 2, 3. I think I used this one. 1, 2, 3. 3 carbons, then a hydrogen. 1, 2, 3, 4, 5, 6, 7, 8. This one. 3, 4, 5, 6. Did I use this one? 1, 2, 3. That is carbon 1, 2, 3. 1, 2, 3. Yes, 4. This one was wrong then. It wasn't among these, but it's a correct structure. It was among. Draw the structure formula of a compound which turns blue litmus paper red. It wasn't among these. So the one that we have found is this one. So this one is similar to this one. How? Because I can just rewrite it. They like twisting things, as I told you. I can write HC, then these two, or oxygen. I can just write 1 and put a 2 here and put H here. Then I have arrived at that one. Now to draw a structural formula for this one, let me just push it here so that we rub this other part. Okay, let me just rub the whole part here. And like this. So now we are writing this one. So it is an acid. So since it's an acid, so this one is wrong. We can consider having a carboxyl group like C, like this, or H. So we have only one carbon there. So we have written COOH. So we have picked COOH. So we only have one H this side. You have seen. So that is the answer there. So COOH and this H. So this is the structure they wanted. They draw the structure formula of a compound which turns blue litmus paper red. So it is a carboxylic acid. Then they're saying, C, choose 2 compounds which are isomers. So isomers are organic compounds which have the same molecular formula but different structural formula. Let me define for you isomers in case a question comes to define isomer. So isomers are organic compounds which have the same molecular formula but different structural formula. So that's what the isomers are. So now they should have the same molecular formula but different structural formula. So we go here and see which one seem to have the same molecular formula but different structural formula. If we check at this one, if we try to count the number of carbon, 1, 2, 3, 3 carbon, here 1, 2, 3. So I'm trying to answer for this one. I'm looking at this because the rest are, I can't see them. I'm looking at this one and this one. So start counting the carbon, 1, 2, 3. So say carbon 3, then we'll go to hydrogen. Hydrogen, how many? 1, 2, 3, 3, 4, 5, 6. So say 6. Then oxygen, 2, right? We have seen 2, so 2. Then we'll come also to this guy, carbon, 1, 2, 3. So say C, 3. Then we go to hydrogen, how many? Here 3, 4, 5, 6. So 6. Then oxygen, how many? 1, 2. So O, 2. So you have seen these, it means this one and this one, they're isomers. What I've written this one are called molecular formula, but in terms of structures, they're saying this appearance and that one, they're different. So in answering, we are going to say this and that are the one. Choose two compounds which are isomers, this and that. Then D, which two compounds can undergo esterification? Esterification is the process by which alcohols react with carboxylic acids to form esters. So let me define this so that maybe it comes in an exam to say define esterification. So we are saying ester or esterification is the process is the process is the process by which alcohols react with carboxylic acids to form esters. Okay, that's what esterification is. So when they say which two compounds undergo esterification, meaning they want to identify an alcohol and a carboxylic acid. So when we come back here, you find that this one is an alcohol because it has OH. Then this one is a carboxylic acid. It is this one, we already identified it. So it is this one and that one. So here we have to say this and that. I think this one, does it qualify to be carboxylic acid? This one is an alcohol. Let's say C. Let me put like C2. I'm just putting this to C. 1, 2. Then H. I'm getting this to H. This 3 to 5. Then this COOH. I put COOH. Now I want to get that formula to see if I'm going to arrive at this one to agree if it is a carboxylic acid. So remember the general formula of C, N minus 1, N minus 1, then I have H here, 2n minus 1, and COOH. Now I'll start with n is equal to 2 because when we tried n is equal to 1, it didn't qualify. So let's try n is equal to 2. So here we have C, we'll put 2 minus 1, H, 2 times 2 minus 1, COOH. So this one will be just C, because 2 minus 1 is just 1. Then this is this 2 times 2, 4. Then minus 1, 3. So it will be C, 3. Then COOH. Has it become that one? No. We'll try n is equal to 3. So I'll solve from here. N is equal to 3. I'll say C, 3 minus 1, H, 2 times 3 minus 1, COOH. Then I'll say 3 minus 2, 1, 2. So I'll put 2. Then 2 times 3, 6 minus 1, 5H5. Then COOH. Yeah, it has qualified. So this one was correct. Okay. So then, even this formula I had put here was correct, which I considered wrong. It was also correct. It is either this one or this one. So this one was also correct because this one is C3. I said, no. This one is C3, C3, then H, 1, 2, 3, 4, 5, 6, 7, 7. And this one COOH. No, this one was still wrong because C1, 2, 3, 1, 2, 3, 4. No, this one was still wrong. Gosh. Okay. Unless if it was like the one we have done, like C, that one we have is C2H, H5, COOH. So this one or this one. So this one, in terms of structure, it can be written as you put 1, 2, see, and you give it, or you give it 1, 2, 3, 1, 2, then you put H, 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 then you add this part, say C, then you put that one, you put that one like that. That's how this one can be written like this. So if I had written, you write this or this, not this one. Okay. So here, which two compounds can undergo esterification? It's this, an alcohol, and this, which is a carboxylic acid. Then we go to this question. It says C1 came in another year. On the packet of a particular opaque beer is written contains 5% alcohol per unit volume. On a packet, okay, on the packet of a particular opaque beer is written contains 5% alcohol per unit volume. A. Name the alcohol found in the opaque beer. Then A. So here they made the mistake. If they said A, name the alcohol found in the opaque beer, they cannot again give Roman numeral 1. No. they should have just said B, then Roman numeral 1 may be described. So then this one should have been C, not you say A, you ask a question again, Roman numeral A, 1 and 2 again a question. No, it doesn't work like that. So A, name the alcohol found in the opaque beer. Then Roman numeral 1, describe in outline how this alcohol you have named in A above is commercially produced from starch. Then 2, write down a balanced chemical equation for the formation of the alcohol from glucose. State symbols not required. So B, give one use and one bad effect of the alcohol found in beer. So we'll start answering. So A, name the alcohol found in the opaque beer. The alcohol found in beer is usually ethanol. Then 1, or go for 1, which they gave wrongly. Describe in outline how this alcohol you have named in A above is commercially produced from starch. Like how ethanol is made from starch. So you describe in outline, like give out like in point form. So here we said a solution of glucose or sugar is mixed with yeast and allowed to react for a few days in the absence of ethanol or of air. Then 2, the enzyme zymase in yeast catalyzes the fermentation of glucose into ethanol and carbon dioxide. Then 3, ethanol is separated from the final mixture by fractional distillation. Yeah. So these are the steps that are followed in commercially making alcohol from starch. So we go to Roman numeral 2, which said write down a balanced chemical equation for the formation of the alcohol from glucose. State symbol not required. So now we write a balanced chemical equation for the formation of the alcohol from glucose. So this is the equation. So this is glucose produces ethanol plus carbon dioxide. So this is the balanced equation. Then we go to the other question here. B. Give one use and one bad effect of the alcohol found in beer. So we'll answer it that way. Use. So ethanol can be used as fuel or solvent or beverage ingredient. Bad effect. Impaired judgment, like people when you drink it, addiction, or liver damage. Okay, that is all. We move to the next question, 18A18, which came from another year, from section A. When ethene is bubbled through aqueous bromine, the solution turns. When ethene is bubbled through aqueous bromine, the solution turns. So it turns colorless. So this is an identity of a double bond or an identity of unsaturated hydrocarbon. Unsaturated hydrocarbon have got the ability to decolorize bromine. Bromine is brown, but it is decolorized once it is reacted with an alkene. So when ethene is bubbled through aqueous bromine, the solution turns colorless. Then A19, methane is a greenhouse gas. Methane is a greenhouse gas. Which process releases methane into the air? So is it A, combustion of petrol, B, decay of vegetable matter, C, volcanic activity. Then D, photosynthesis. It is B, decay of decay of vegetable matter. So these releases, like things that are decaying, they release methane into the air, and mostly this methane should be the gas that can also be obtained from feces or toilet things. Like if animals like cattle, goats, when they fat, in their fat there must be this gas methane. And according to my hypothesis, those cattle keepers, when they are moving behind the cattle, they're fatting this methane and they're breathing this. It affects them because people say those guys are not normal. My hypothesis is because of methane which they continue breathing on should be affecting them. So we go to C1. The structure below is for a polymer. So this structure is for a polymer. You see the one which I showed you, the other one, where they write CH3. So this is a polymer with three repeating units. 1, 2, 3. You see this guy is the same as this guy, So they are repeating. Now they're saying name A, Roman numeral 1, you name the polymer, should name this polymer. Roman numeral 2, name and draw the structural formula of the polymer, of the monomer for the polymer. Name and draw the structural formula of the monomer for the polymer. Then B, Roman numeral 1, state the type of polymer that is shown above. Then Roman numeral 2, give one use of the polymer. So we'll start answering right away. So we did this. So this polymer, for you to name it, you just look at a repeating unit. The repeating unit has got how many carbon? 1, 2, 3. It means this is propene. Okay? 3 carbon meaning propene. Like I told you in the other revision. What did I say in the other revision? Like how we name. So for alkenes, for instance, the first member is N is equal to 2. And N is equal to 2, it means if. And if it is an alkene, it will be ethene. Then N is equal to 2, meaning carbon atoms is equal to 2. I mean 3. It means prop. And for an alkene, it will be propene. N is equal to 4, it is equal to bute. For an alkene, it will be butene. Just like that. So now, the one which has got N is equal to 3, which means 3 carbons. This one, 1, 2, 3. So it, as you can see, it is prop. So prop is for propene. Now this polymer, it means since this is propene. So to be a polymer, you just add polypropene. So when they say name the polymer, it will just be polypropene. Sometimes they call it polypropylene, but we are used to this polypropene. Now they sometimes call it polypropylene. Okay, then we go to Roman numeral 2, which says name and draw the structural formula of the monomer for the polymer. So the monomers I've already said it is propene. So if they say draw, it will be like this. I decided to put it like this. Now if we want, okay, let me return. Now if we want, we could have written it in the way they've given it. So this is a monomer, the same repeating, the same one repeating. So just pick this one, which is repeating, C, C. Here we have CH3. Bond there, we have CH, then C, then H there, then H there. Now, this carbon which is here, half of it and this half, they were broken. So you join them and bring them here. Here. Okay. So this one and this one, they're just the same, except I picked the one which was already written. With this guy, they put it on top because they can decide this to put them on top. So either this one or you write it like the way it is, like C double bond like that, then CH3, then H, just the same. Then we move on to the next one, which is B1. State the type of polymer that is shown above, and the Roman numeral to give one use of the polymer. So the type of the polymer, because you add the same monomer repeatedly, it is called addition polymer. Then give one use of the polymer. Polythene, one use is in making ropes, carpets, plastic chairs, food storage tubs, etc. So that's what they use that polymer, polypropylene, for. In making those ropes, they use trackers, carpets, plastic chains, chairs, I mean, food storage tubs, etc. Then we come to the other part which wasn't showing. Ethanol is an alcoholic beverage which can be brewed from cassava. Outline the process by which ethanol can be prepared. Then the ethanol is used as fuel. Construct a balanced chemical equation for its complete combustion. So start answering like, for ethanol is an alcoholic beverage which can be brewed from cassava. Outline the process by which ethanol can be prepared. So in answering, we can say a solution of glucose is mixed with yeast and allowed to react for a few days in the absence of air. The enzyme zymase in yeast catalyzes the fermentation of glucose into ethanol and the carbon dioxide. Ethanol is separated from the final mixture by fractional distillation. That's all. Then the ethanol is used as a fuel. Construct a balanced chemical equation for its complete combustion. So ethanol can be used as fuel, like in Brazil, they mix it with a little petrol. Some they use it as it is in a pure because it is flammable. So it can work because it burns. Something which can burn can be used as fuel. A fuel, in other words, is anything that burns to produce heat, like charcoal. Can you say charcoal is a fuel? Yes, it's a fuel because it burns to produce heat. Firewood, yes, it is fuel. It burns to produce heat. So ethanol also, because it burns, it can be used as a fuel. Now they are saying you construct a balanced chemical equation for its complete combustion. When it burns, what is its equation? So this is it. So this is ethanol reacts with the oxygen to form carbon dioxide and water. So when you balance, there's a 3 here, a 2 here, a 3 here. Okay? Then we move. This is another question which came in another year. Proteins are naturally occurring macromolecules. Proteins are naturally occurring macromolecules. A1 define the term macromolecule. So we're saying a macromolecule is a molecule of very large molecules here, formed by the joining of many small repeating units or monomer. So a macromolecule is a large molecule. Let me just rewrite this one properly. Yeah, so I'm saying a molecule is a very large molecule formed by the joining of many small repeating units or monomers. So yeah, that's what a macro, the word macro just means large. Macro means large molecule. So macromolecule is a very large molecule. Now, you say formed by joining of many small repeating units. They can be repeating units or not. Then, two, name another naturally occurring macromolecule. Another naturally occurring macromolecule can be cellulose or starch. So protein, starch, or cellulose are examples of natural macromolecules. Then B, proteins can be hydrolyzed to amino acids. State a suitable reagent and condition for this hydrolysis. So remember in that other question we found hydrolysis of proteins. They asked what are the products. This time they have already showed us the products. So proteins can be hydrolyzed to amino acids. State suitable reagent and condition for this hydrolysis, meaning what reagents are there to ensure that this happens and under what conditions. So we are saying reagent, concentrated hydrochloric acid. Condition, heat or temperature of about 100 degrees Celsius. Then we move. C. The structure of a section of a protein can be represented as shown here. So this is a structure of a part of a protein. Now they're saying describe one similarity in the structure of a protein and the structure of nylon. So when you look at nylon has this link here, it's their similarity. So you can say both polymers contain the amide linkage joining their repeating units. So they have got this amide CONH. So this is a linkage. So proteins will have this, and also nylon will also have this. Then B, describe one way in which the structure of a protein differs from structure of nylon. Okay, so they're saying how can now this one differ from that structure of nylon? We're saying okay, proteins have different side chain or R group on each amino acid unit, whereas nylon's repeat units are identical. Yeah, so in other words, we are saying in monomers for proteins, their side chains are different, while in monomers for nylons, the side chain are identical, same. Then we come to this question 10, which came in another year. They're saying ethene, which is C2H4, is a hormone found in most plants. Ethene C2H4 is a hormone found in most plants. Tomatoes releases ethene as they ripen. Fruit growers use ethene as a ripening agent. Now they are saying A. Draw a displayed structural formula of ethene. B1. State the homologous series to which ethene belongs. 2. Give the general formula of this homologous series. 3. State the molecular formula of the 4th and 5th members of this homologous series respectively. Then C. State one major source of ethene and the method by which it is obtained. So we'll start answering. So A, we are saying draw a displayed structural formula of ethene. So it will just be like this. So you just put, this is an alkene, there will be double bond. So you just say, oh, this is C2. Oh, let me just put C and C and give them a double bond between them. Then, oh, they have 4 hydrogen. So meaning each one must have 2. Put here hydrogen, put here hydrogen. That's all. This is a displayed structural formula for ethene. And you must make sure that each carbon is surrounded by 4 bonds. These lines represents 4. 1, 2, 3, 4. This one also 1, 2, 3, 4. So this is the one. Okay. So we move on to, or so it can be written like this or this. Sometimes we bend them, sometimes we can straighten them at your level. This does not matter. Then we come to B. We are saying B1 state the homologous series to which ethene belongs. So homologous series, as we said, these are different organic families which have the same functional group. They share the same general formula. They have same chemical reactions and can be prepared by the same method. So that's what is homologous series are. Different families, like we have the alkene homologous series, the alkane homologous series, the alcohol homologous series, the carboxylic acid homologous series, then we have the ester homologous series. So these are homologous series. Now ethene, from these I've mentioned, which one does it belong to? So we can say A, B Roman numeral 1, it is alkenes. Then Roman numeral 2, give the general formula of this homologous series. So these, they share the same, alkenes share the same general formula, which is CnH2n. Then 3, state the molecular formula of the fourth and the fifth members of this homologous series respectively. So there will be this. Fourth, it is C4H8, then fifth C5H10. Now, how can you know? You just use this formula. We are using this formula here. So, fourth and fifth, meaning fourth, meaning N carbon, number of carbon is 4. So, just pick this formula. Say, okay, see where there's N, I put 4, H, then you put 2, times where there's N also you put 4. So this one will give you C2, then H, and say 2 times 4, 8. Hence this one. Then for the fifth one, it means N is equal to 5. So say, okay, N is equal to 5, I'll pick C here, I'll put 5, H, then I'll put 2 times 5, then I'll have C5, or here is 4, sorry. So I'll say 5, then 2 times 5, 10. Hence this one here. So that's how it is done. Then here they're saying, C, state one major source of ethene and the method by which it is obtained. So one major source of ethene is petroleum or crude oil fractions. By what method can it be obtained? Either steam or catalytic cracking of long chain alkanes. So it can be steam or catalytic cracking of long chain alkanes. Then we go to this question. Are we done? We are done. We come to D. Two of the substances made from ethene are shown below. Two of the substances made from ethene are shown below. So, this substance can be made from ethene, and this can be made from ethene, substance R and substance S. They're saying, name the substance S, R and S. When you look at this one, it has this part OH. This one we call it hydroxyl group. So hydroxyl group, it is a functional group for alcohol. This one is what we call functional group for what? For alcohols. So meaning a functional group is an identity. It's a surname. It's like to you, surname. Children born from the same father will have the same name. So alcohols will have the same functional group OH as their identity. That's how you can identify. So this one is an alcohol. Now this one, it is what? It has these lines down here broken, meaning they are not attached. And I mean, it means it's a polymer. Now, it's a polymer of who? Locate two repeating units, this one and this one. It means it is a polymer of two carbon. You identify just one. Two carbon, it means it's ethene. Now, if it came from ethene, it can be called polyethene. So this one is polyethene. So this one is an alcohol. Now, if an alcohol has two carbon here, it is just ethanol. Remember, two carbon means eth. So this one is ethanol. And alcohol ends with O, L. So this one is ethanol. So, yeah. So now, like they said, name, say R is ethanol, and then and S is polyethene, as we have already stated. Then they say state one use of substance S, this one here, like polythene. The same, making plastics, plastic bags, bottles, packaging film, household containers. Any of these can qualify as the answer. Okay, so we go to another question which came in another year. Study the flow diagram below carefully. Study the flow diagram below carefully. Heavy oils, they undergo process A, they produce substance B. Substance B undergoes process C, produces ethanol. Then they're saying A, name Roman numeral 1 process A. If you have a heavy oil, heavy oil produces substance B. What have you done to a heavy oil? You have cracked it. So cracking or catalytic cracking. Process C, when you crack these hydrocarbons, where do they go? You form alkenes. Here, what you form are alkenes. Cracking heavy oils, which are alkanes here, can produce alkenes. So now, these alkenes, they are now producing ethanol. So what is this process leading to formation? So this is hydration. If you hydrate, you add water to this. So this is cracking. You crack it. This should be hydration, like you add water. So Now, the way they were saying, to say, process C is hydration addition of steam or water. Name substance B. Now, substance B, specifically we cannot name because they are many. They are alkenes actually, but I decided to say ethene because specifically what gives ethanol is ethene. From alkenes, what gave ethanol was specifically ethene. If you hydrate ethene, it will give you ethanol. Now, how? This is it, how it goes. You have ethene, which is C2H4. Then you react it with steam, hydration of water. So what will happen? It will form an alcohol. An alcohol have OH at the end. So you have picked one H here and O here. You have remained with one H here. So one H added to this, so it will be C2H5. So this one is ethane. So that's how it occurs. So one hydrogen comes here to form 5, then C2. Then you have now this. So that's how ethene can directly give us ethane. Now let's move to this. Give one significance of process A. Cracking. What is the importance of cracking? We are saying produces more variable, smaller molecules, e.g. petrol or alkenes for polymers. Another one we can say increases supply of feedstocks for petrochemicals. So that's the importance of cracking. I think we even discussed in another revision. Then we come to this D. It said pterylene has the simplified structure shown below. Pterylene has the simplified structure shown below. So this is pterylene. Now they're saying Roman numeral 1, state the functional groups on the monomers used to make pterylene. So pterylene is made from alcohols, which are diols alcohols. These alcohols are diols, that's what they are called. It is also made from dicarboxylic acids. Dicarboxylic acids. So on alcohol and dicarboxylic acid become the monomer when they state the functional groups on the monomers used to make pterylene. So alcohol, the functional group is OH, the carboxyl, hydroxyl. It is called hydroxyl, as I already mentioned. Then for carboxylic acid, the functional group is COOH. It is called carboxyl, like that group. So these are the ones they wanted. So in answering, we'll say this one actually it should have a carbon here and this one a carbon there. So it is this one COOH, carboxyl, and OH hydroxyl. So these are the functional groups found on monomers that are used to make pterylene. Then 2, state the type of polymerization that occurs when pterylene is made. The type of polymerization is condensation polymerization. Then E, many problems are caused by the disposal of plastics. Describe one method of disposal of plastics and a problem caused by this method. Many problems are caused by the disposal of plastics. Describe one method of disposal of plastic and a problem caused by this method. So In answering, we can say incineration, which is burning. It's one way of disposing plastic. Now, what problem does it cause? It reduces volume, but releases toxic gases like hydrogen chloride into the atmosphere and dioxin. So these are toxic gases. Another method of disposal is land filling. So land filling takes up land, persists for decades and can leach pollutants. Then recycling, energy intensive and requires careful sorting. Not all plastics are recyclable. Then we go to this question which came in another year. Ethene, which is C2H4, burns completely in air to form balanced equation for the reaction. Ethene C2H4 burns completely in air, okay, to form a balanced equation for the reaction. Okay, the equation wasn't okay though. They were just supposed to say ethene burns completely in air to form carbon dioxide and water. Then they say which of the following is a balanced equation for the reaction. So this one, the typing wasn't complete. So the answer here is D. Ethene plus oxygen gives us carbon dioxide and water. You can think this is an answer. No, this is an answer, but the equation is not balanced. This one is not. This one is not. Then 18A, the organic product of the reaction between this is an ethanol and the carboxylic acid is. So ethanol and the carboxylic acid, when they react, they will give us an ester. And such an ester is known as the name of an ester comes from the name of the alcohol. So this alcohol is methanol. And this acid is methanoic acid. This is good. So these two, when they react, it will form methyl methanoate. Methyl methanoate. So this one is an ester. So now they say the organic product of the reaction between that one is. So an ester. Now we don't know which one will be an ester here until we start reacting these. So sorry, we have been shown an answer by clicking by mistake. I clicked by mistake. So however, we need to drive an answer. So what happens is this. This is an alcohol. This is an alcohol. So this is an ester. An ester forms the first part. Like if you have an ester, let me show you how they react. An ester, the structural formula is C. I'll write the functional group like COH. I'll write COOH, COOH, then with this H here. If it is reacting with an alcohol, this one, I'll also write an alcohol like, I'll just put this side behind here. It will be HO, then this carbon with the 3 hydrogen. 1, 2, 3. So what happens? This one loses this. So this one will be lost and this one will lose this one. So yeah, so it will come and join. So these two, they will join each other. So it will be H, C. Then here I can just even draw like this. This oxygen will come here. Then I'll draw this one. So this one will be now the ester plus this OH and H, they form water. Okay. So now this will be the acid, the ester they form. This is now what we call methyl methanoate. Now it starts with this. It will start with the. Now in writing this one, you can see that we can have H, then we have C, then we have OO, then now we can have CH3, CH3. Which one is this one? You have seen, this is how we arrived at that answer. So that is how to arrive at that answer. That is the process going on here. Then 19, the same. Choose the correct monomers of pteridine. Remember, pteridine, which is PET, is made from diols and dicarboxylic acid, meaning alcohols and dicarboxylic acid. So these are the monomers. So the answer is A. We move 20. The displayed structural formula below are of different compounds. Which ones are isomers? The displayed structural formula below are of different compounds. Which ones are isomers? Remember, isomers, I said, are organic compounds which have the same molecular formula but different structural formula. So let's see which one will be isomers. This one will start with V. V, how many carbon? C carbon, how many? 1, 2, 3, 4. 4 carbon. Then, how many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So say hydrogen 10. Okay? You see, we will go to W. Or say carbon, how many? 1, 2, 3, 4. 4. Hydrogen, how many? 1, 2, 3, 4, 5, 6, 7, 8. 8. Then we'll go to X. X, this one. How many carbon? 1, 2, 3, 4. So carbon will say 4. How many hydrogen will count? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Then we'll go to Y. Y, how many carbon? 1, 2, 3, 4, 5. 5. We'll go to H. How many H? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12. So now, isomers are organic compounds which have same molecular formula but different structural formula. So when you see V and X have the same molecular formula, C4, C4, H10, H10. But when you look at their structures, this structure and this one, they are different. So these are isomers. So when the question said which one, it is these ones. So structures V and X both have the formula this, but different arrangement of that. So they are isomers. So the answer is what? The answer is V and X, which is D. VXB. We go to the next question. This question says the diagram below shows the preparation of liquor in a village. So it is coming from alcohols, liquor there. Okay. Then they're saying name the process demonstrated above. B, Roman numeral 1, name apparatus B, that one. Roman numeral 2, if this experiment was done in the school laboratory, what name would be apparatus B and C? What would be this apparatus? A and B, I mean. Then C, what is the scientific term for the liquor or liquid in the experiment? In the experiment here. So we'll now start answering. So the name the process demonstrated above. It is fractional distillation, this one. Because there will be water that will come out, and then there will be alcohol and water. So this one is part of fraction. Then 2, they're saying B2, name apparatus B. Apparatus B here is just a condenser. Okay. Then we'll move a bit to answer Roman numeral 2. If this experiment was done in the school laboratory, what name would be apparatus B, apparatus A and B? A, this one, will be actually a distillation distillation flask. A can be a distillation flask or round bottom flask or boiling flask. Then this one B would be a Liebig condenser. Liebig condenser. Then we come to C. What is the scientific term for the liquor or liquid in this experiment? So that liquid, I think it's just ethanol. So we go to this other question which came in another year. The series of processes below show the links to the formation of an ester known as ethyl ethanoate. They're saying the series of processes below show the links to the formation of an ester known as ethyl ethanoate. So we have ethene undergoes process C, K forms ethanol, ethanol undergoes process L, forms P, P undergoes process M to form, P undergoes process M to form ethyl ethanoate. Then they're saying A, from the reaction scheme above, name processes K, L, and M. B, construct the chemical equation describing process K, include state symbols. Then C, state both the chemical name and common name for substance P. This one. Then D, state the general formula of the series where substance P belongs. Then E, give any two uses of ethyl ethanoate. So start answering. A, from the reaction scheme above, name process K, L, and M. So if ethene undergoes process K to form ethanol, that process is hydration. Then, if ethanol undergoes a certain process to form P, that P again forms ethyl ethanoate. So it would undergo a process of oxidation where ethanol becomes an acid, ethanoic acid. So this ethanoic acid can now turn into ethyl ethanoate when it reacts with lead to ethanol. Remaining, it can form ethyl ethanoate. So this is K is is hydration, L is oxidation. Ethanol undergoes oxidation, forms ethanoic acid. Then ethanoic acid can react with the alcohol remaining to form ethyl ethanoate. So this process is esterification. So in answering, we are saying K is hydration of ethene. Then L is oxidation of ethanol to ethanoic acid. Then M is esterification, condensation between ethanol and ethanoic acid. Okay? Then we move on to the next question. So B, construct the chemical equation describing process K. Include state symbols. So I don't know if I remember adding state symbols. So ethene should react with steam to give us ethanol. So we have, okay, I did. So this is ethene, it is in gas, undergoes hydration, which is the addition of gas, water vapor there, under phosphoric acid catalyst, it will form ethanol in liquid form. This is a balanced equation, including state symbols gas, gas, liquid. Then we move on to the next question, which is C. State both the chemical name and common name for substance P. So substance P, we said ethanoic acid. State both the chemical name and common name for substance B. So this one is ethanoic acid, which is vinegar. So we'll say chemical name is ethanoic acid. Common name is acetic or vinegar acid. Then we go to another question, which is to state the general formula of the series where substance P belongs. So we need to state the general formula of the series. So this one, P is a carboxylic acid. So what is the general formula for carboxylic acid? This is the general formula here. So carboxylic acid, the general formula is CN minus 1, then H2N minus 1 COOH. Then we are saying state the general formula of the series where P belongs. Here it's this one. So this is the one we can use to know this and this, just using this one. Then we come to E, give any two uses of ethyl ethanoate this ester. What two uses? What uses does it have? Two, just give two. So we can say solvent in varnishes, paints, and adhesive. So this one is used as solvent in varnishes, paints, and adhesive. Two, nail polish remover. It can be used to remove nail polish or degreasing solvent, removing grease. Then, three, fruit flavoring and perfume ingredient. So esters are used in fruit flavoring or perfume ingredient. So they needed two, so you can give any. So we go to this question, which was from section A, question 18. Three reactions involving ethanoic acid are represented by the letters X, Y, and Z as shown in the figure below. So we have reactions involving ethanoic acid. So we have ethanoic acid here. It undergoes this reaction, sodium ethanoate. Then this ethanol undergoes this reaction, it forms ethanoic acid. Then this ethanoic acid undergoes this reaction, it forms ethyl ethanoate. Then they're saying which of the reactions X, Y, and Z involves oxidation? Oxidation is this one here, ethanol turning into ethanoic acid. So this process is oxidation. So the answer is A. We go to 19A. The table shows the result of tests carried out on compound X. The table shows the result of tests carried out on compound X. So tests on compound X is bromine water added, results decolorized. Another test on substance X, sodium carbonate added, result colorless gas evolved. Now, the question was, which formula represents compound X? So, you have to understand this compound X should be which compound? Number one, it is reacting with bromine to decolorize it. Number two, it is reacting with sodium carbonate. So, what could be this substance? So, this substance, from the look of things, it is only an acid, say carboxylic acid. Because carboxylic acid have got a double bonds, they are able to decolorize bromine water. Because they are acid, they are able to react with carbonates to form carbon dioxide. So, this one is not a carboxylic acid. This one is an ester. This one is a carboxylic acid because it has COOH. This one. This one, it is not. This one, it is not. This one is not actually. This one it's not because it has another one here. Okay. So this one is the one. Because of that one, those have given a double bond there. That double bond doesn't matter really. So it is this one. So the answer is D. So we go to this question again. Butane and the methylpropane are isomers. Butane and methylpropane are isomers. Which formula is different for the two isomers? So for isomer, we said for isomers, they have same what? Same molecular formula. Which one is different? They have different what? Different structural. So when they say which formula is different from the two, it is actually the structural formula. Then we go to this question, P7. The diagram below shows an arrangement of outermost electrons in a molecule of a compound. Okay, so this diagram shows an arrangement of outermost electrons in a molecule of a compound. Okay, so we have this carbon, carbon, hydrogen, hydrogen, hydrogen. Okay, so then we have oxygen, oxygen, hydrogen. So we have how many carbon? Two. One. This carbon here has how many hydrogen attached? One, two, three. So you put three hydrogen attached to it. Then you have another this carbon. This carbon has how many? Has hydrogen, oxygen, oxygen, hydrogen. So it says this other carbon has oxygen, oxygen, and the hydrogen. So when we look at this one, this compound is a carboxylic acid. Okay, so having identified it, they're saying one, on the diagram indicate a double covalent bond by putting a circle around it. So here in this overlap, there are two electrons. These are single bond, two electrons. In this overlap, two electrons. In this overlap, two electrons. In this overlap, there are 1, 2, 3, 4. So this is where a double bond is. So they said we circle where a double bond is. Circled there. Then Roman numeral to construct the chemical formula of the molecule above. It's this one here. We have already constructed it, CH3COOH. Then we come to calculate the molecular formula of the compound. I never calculated because this is found in more concept, but I can still do it for you. So this is CH3COOH. So molecular formula like CH3, CH3COOH. So molecular formula, molecular mass, total mass of relative atomic masses here. So you have carbon, which is 12, hydrogen 1, this carbon 12, these oxygen each 16, then this one 1. You get from periodic table. So you start totaling them. 12, or just because there's 12 and 12, I'll just say 12 times 2, because there are 2 of them there, this 12 and this 12. Then we'll just say this one plus hydrogen, there are how many? You can just say there are 4, this one and this one. So 4 and there are 1. So there will be 1 times 4. I've added this one and this one, 4, because they are having 1, 1. This is the 1. Then I say plus. Then oxygen, there are how many? 2. I say 2 times each one has 16. So this one will be 24 plus this one will be 4 plus this one will be 32. So let's add 24, 32 and 4. So this one, it will be 6, 4, 0. This one plus this one, it will be 5 plus carry 1, 60. So it will be 60. Okay, yeah, I left it out, but I'll say, okay, I'll solve it for them. So I've seen that is 60 here. Now they're saying B1, to which homologous series of compounds does the molecule belong? So that one is an alcohol. So, oh, it's a carboxylic acid, so it's a carboxylic acids. Then to state one chemical property of the molecule, like what are some of the chemical properties of carboxylic acid? Okay, you can say react with metals or carbonates to produce hydrogen or carbon dioxide. You can say 10 blood litmus red in acid, just like that. Then we go to 17A. What is the structural formula of the ester formed when ethanoic acid reacts with propane? Again, you have ethanoic acid reacting with propane. Now here I brought some details. I said when forming an ester has this one here, a linkage, which we call ester link. Okay, this is an ester link, which is mostly found in terylene. Now, when an ester is formed, it is formed from an alcohol or from an acid, like in this case, ethanoic acid, and an alcohol. Propanol is an alcohol here. So, this is an idea to show you that when you have a formation of an ester, it will have a link. The alcohol part will be this side, and then the acid part will be this side. For instance, like this one. So you have, this is the link here. The acid part will be this side, then the alcohol part will be this side. So now, this one and this one, from acid, from alcohol. Okay? Now, how do they form? So this is how they formed. I actually produced this. I got the diagram from the notes. You have ethanoic acid. This is how it is, 2 carbon. Then you have what? Propan. It has 3 carbon. So this one loses what? Loses OH. This one just loses H. So this and that give water. And when this loses this comes to join here. So this part is this part here. Then this part is this part here. Then this carbon comes here. Then this oxygen comes here. And this part comes here. So now, this is it. So this one now, by naming it, you get this name, this part which came from, you name it starting from the alcohol part. The formula is different. Writing the formula, you start with the acid, then you end with the alcohol. Now, when naming, you start with the alcohol, you end with the acid. That's why this acid, this ester, if I were to be asked the name, it would be propyl ethanoate. It will start with ethan, with propan, propyl ethanoate. So now, they want now the structure. What is the structural formula? So this one should be the molecular, but they are also calling it structural formula. So to know, you just move, you can make it from here. You can say C3. You start from here, C, you give this hydrogen 3. So say C, this one, then hydrogen amino 1, 2, 3, you say H3. Then you say COO, COO. Then you come to, you give this one, C, you give it to, this one has 2 carbon, you say C, or it has 2 hydrogen, 2. This one has 2. Then this one again C2. Then this one has 3, 1, 2, 3. You say CH3. So you have formed a molecular formula. So you check which one is similar to this CH3. This one CH3. Then we have this one have hidden it. The answer is this one. Okay, let's count the carbon here. 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 5. Yeah. So the answer is this one. You have seen CH3, COO. They have hidden it. So this OO, sometimes they can just write O2. They have hidden it. So the answer is B. Then we go to the next question, 18. The table below shows boiling point ranges of fractions collected from distillation of a sample of petroleum crude oil. Which fraction contains the smallest molecules? The smallest is the one with lowest boiling points. So this one here, which has a boiling point range of 20 to 50. These ones are large. Then we come to 19. The diagram below shows the structure of a monomer. So this is a monomer. Then they're saying select the polymer that can be formed from the monomer. So this one, to form a polymer, it will break these bonds. So it will be like carbon, carbon. This double bond, one will break, there will remain one. So these will remain the way they are. There will be still bromine, hydrogen. Then this one is chlorine. This one is hydrogen. Now that double bond, that which was broken, one bond here, part of it will be here, another here. So now it will cause this guy to repeat itself. So there will be another guy here of this same, another guy, there will be many of them. So which one have got like this which will repeat? Is it this one? No. Here, yes, yes, we have that one, but here it's supposed to be hydrogen. Then here, is it this one, this one? Yeah, these guys can be clever, they can swap them. But we have two hydrogen. No, but here we are not having hydrogen on the same carbon. So we have hydrogen on the same carbon, then bromine, no. This one also not. When we come on this one, not. This one not. Because we only have one hydrogen on this. See. This one, yes. Look. Also like that. So the answer is D. I had to put B. Nope. B, that one. Yes. So the answer is not that one. This one. We move to 20. All of the following are condensation polymer except. So condensation polymer except this one here, polystyrene. Then 17, which equation represents incomplete combustion of ethane? So incomplete combustion will have carbon monoxide. So there's this one and this one here. Now we go for balanced equation. Oxygen 2 here, oxygen 2 here, correct? Carbon 2, carbon 2, correct? Hydrogen 6, hydrogen 6, correct? What of this one? Carbon 4, here carbon 4, correct? Here hydrogen 12, here hydrogen 12, yes. Oxygen 10, here, damn, 4 plus 2. Uh, 4, then plus 4, 10. Yeah, this one. Oh, yeah. So, this one they tricked. So, this will give water, actually, carbon monoxide and water. Now, they tricked it following like balance. So, this one is not. It should be water. So, the correct answer is this one, C. I've tried balancing. I've seen that they're all balancing. Now I've realized here there wasn't that. So a complete combustion will give us carbon monoxide and water. Then we go to this 180. The following diagram shows the structure of butene, an alkene which is manufactured by cracking large hydrocarbons. Okay, so this is butene 1, 2, 3, 4. Which hydrocarbon can be cracked to make butene? So this one has how many carbon? 1, 2, 3, 4. This one, you can crack a large molecule to get this. You cannot get, this one has 3, this one of 1 carbon, this one has 2 carbon, and this one has 3, then you get the one which has 4. How? Unless you crack the one which has more carbon atoms. So like this one is the answer. So which hydrocarbon can be cracked to make butene? It's this one here, decane. The 19, which polymer contains only 3 elements? So it was starch. Starch contains the oxygen, hydrogen, and the carbon. Then 20, what is the linkage between the units in terylene? Terylene, the linkage is similar to ester. We call it ester linkage. So the ester linkage is this one, COO. So the answer is B. This one is not a linkage, it is a hydroxyl. This one, it is a linkage in nylon. Okay, so we go to this one here says before. Ethyl ethanoate, that one can be prepared from ethanol and ethanoic acid. Write the chemical equation for the reaction. Okay, so now this one we have ethanol and ethanoic acid to form ethyl ethanoate. So we'll say ethanol to be just C 2H5 or H, then plus ethanoic acid should be C. I can't remember in my brain what it is, so just derive it from this formula: Cn minus 1H 2N minus 1 COOH. So ethanoic acid means 2 carbons, N is equal to 2. So I just substitute 2 there, say C 2 minus 1 H 2 times 2 minus 1 and COOH. Then I'll get C 2 minus 1 to be just C. Then 2 times 2, 4 plus 1, 3. So it will be C3 COOH. Okay, yeah, so C3 CH3 COOH. So this is ethanoic acid. So these two, when they react, they are forming this one. They have already given us here. So this one will be ethyl ethanoate plus water molecule will be released. So it will be CH. Now this one they gave 1 mark. These guys, let them be serious. CH3 CO2 C2H5. Okay, plus water. Okay, I think I wrote that one. Huh? I think I wrote that one. Let me see. I never answered that one. Okay, so we have seen, what have we said? We have said C2H5OH plus CH3COOH, which is giving us CH3, the acid part, then CO2, C2H5 plus water. So this is an ester which will be formed because they're saying ethyl ethanoate can be prepared from ethanol and ethanoic acid. Write the equation for the reaction. So this plus that gives us that, and water is formed. Then they're saying this was a more concept. This is what caused me to leave out this equation, because I thought it is a more concept, but no, this one is there in the preparation of esters. So that's why I've decided to write it. Then this one I left it. Now I want also it to calculate it. They're saying calculate the theoretical yield of ethyl ethanoate which can be obtained from 23 grams of ethanol. So I'll calculate theoretical yield. So of what? Calculate the theoretical yield of ethyl ethanoate, meaning this one. How much of this one can be formed from 22 grams of ethanol? 23. So if this equation is balanced, let me see if it is balanced. Carbon will have 2, 3, 4. Here 1, 1, 2, 3, 4. So we have first to balance. So they are balanced. 1, 2, 3, 4 carbon. Then hydrogen. Hydrogen here we have 5, 6, 7, 8, 9, 10. Here we have 3, 8, 9, 10. 5, 6, 7, 8, 9, 10. Hydrogen balance. Oxygen we have 1, 2, 3. Here 1, 2, 3. So it is balanced. So since it is balanced now, our focus is to look at Since they're saying calculate the theoretical yield of ethyl ethanoate, so we'll only consider what is given, which is this one. Ethanol C2H5OH to what is being asked. What is being asked is CH3, CO2, C2, and H5. So that's what we'll deal with. So here, since it is balanced, we'll use what we call molar mass to molar mass relationship. So first of all, say we are given 23 grams here. What are we going to have this side as for ethanol, the yield? We don't know. So we'll calculate the molar masses of each to use them as a relationship. So here we have 12, here we have 1, here 16, here 1. So I think this one, okay, here we have again 12, 1, 12, 16, 12, 1. So now I'll do the calculation for these guys. Let me see. For this one, it should be, I'm starting with this one, the molar mass. I'm going to get to just use a calculator. Let me just use a calculator direct. I think let me get a calculator so that we help each other. So do this. So I'll start by saying 12 times 2 because carbons are 2 here. Here I'll say 5 plus 1, there will be 6 to be 12. So here there will be just 6 because of that one. Doesn't matter. So I'll say 12 times 2 plus here 5 plus 1, 6. It will just be 6 plus this 16 here for oxygen 16. I'm getting 46, so I'll put 46 here. Then I'll say, what is it here? Here again, I'll add. I have how many carbon? Carbon are many here. I have this carbon, that carbon. So now, I just want to lessen my work. So there are 2, 3, 4. So just say 12 times 4 plus, then the hydrogen there, this is 5 plus 2 plus 3, 8. So I'll say 8. Yeah, 8. Then plus, then I've done carbon, hydrogen, then oxygen there are 2, 16 times 2, 16 times 2. So I'm getting 8. I don't know whether I'm correct here, but what I'm doing is the process that you have to take. So say 8, 8. Then you cross multiply to find x. So 46 times x to be 46x equals, so say 23 times 88. So 88 there times 23. We are getting 2024. So have 2024. So now to get x, we divide by 46. Also here by 46. So that this goes. So now you have x, you say x. So say x is equal to You say this answer divided by 46, we are getting 44. So this will be 44 grams. You say, then you say, calculate the theoretical yield. So say 44 grams is the theoretical yield for ethyl ethanoate. Okay, so now that's the answer. So now we'll go to the next question. The next question is saying, if 33 grams of ethyl ethanoate is produced, calculate the percentage yield. So percentage yield, you do like this. Percentage yield is equal to actual yield over theoretical yield times 100%. So they're saying if 33 grams of ethyl ethanoate is produced, calculate the percentage yield. So this one becomes the actual. So say, okay, 33 grams over, that one we calculated was theoretical, 44. Yeah. 44 grams times 100 degrees. 100%, not degrees. So now we are going to get our calculator to see the answer now. So we'll say, okay, we'll say 33 divided by 44 equals 10 times 100 equals 75%. So this one will be 75%. So this is the percentage yield. You have seen that? So yeah, that's how we do it there. Then they're saying to which homologous series does ethyl ethanoate belong? So say ester. I didn't even answer the whole of this question. Sorry, I ignored the whole of this question. I don't know why I ignored it. So this is ester. Ethyl ethanoate is an ester. So now we continue. So this one was B8. The structures shown are members of one of the homologous series in organic chemistry. So these structures shown here are members of one of the homologous series in organic chemistry. So they all have OH, OH, OH. So what homologous series do these belong? Alcohols. So if they say A, give the general formula for this homologous series. For you to give the general formula, unless you know which homologous series is this, so the alcohols, the general formula is this one, CN H2N plus 1, or this one here. In the same B, what is the functional group for the homologous series? The functional group is this one here. They all have OH, which is the hydroxyl group. So I can say hydroxyl group, which is a double carbon OH. Then they're saying C, S is used as fuel because it burns in oxygen. This one here, S, which is ethanol. Write a balanced chemical equation for this reaction. This would be it. Ethanol plus this oxygen, it would be carbon dioxide and water. Then D, which of the compounds R, S, or T would have the highest boiling point? The one with more carbon atoms, so it would be T. So say T, it has the largest molar mass and stronger van der Waals forces. Okay, then we go to the next 18. Some organic compounds are generally non-reactive due to lack of a specific site for chemical attack. Which of the following is such a compound? Some organic compounds are generally non-reactive due to lack of a specific site for chemical attack. Which of the following is such a compound? So some are non-reactive, are considered less reactive because they don't have what they call a specific site. So a specific site for chemical attack is also known as a functional group. Like alkenes, at least they have. If you say alkenes, their site is actually double bond. For alcohols, them it is actually carboxyl group, hydroxy. For like carboxylic acid, carboxyl, then ester, the COO. Now, for alkanes they don't have such. So when they say which of the following is such a compound which is non-reactive, it is this one which is an alkane. The rest have this one has this one has this. So these they don't have. So the answer is B. Then we come to 19. Choose one organic compound that makes up 98% of natural gas. Natural gas is mainly made of methane. Okay. When we come to 20, which of the following structures belong to the same homologous series of compounds? They belong to the same homologous series. Like let's see this one. This one. Let me go for one. 1C3H8. H8. Then 2, it has C, this one here. It has, I'll start with C3, I've hidden it. C3, then I've started with this one, then C2. You like hiding this C2, then C2 again. C2, then OH, this one here. Then I'll come to this one, 3. It has, even in this one, I've hidden it. But no problem. I'll count 1, 2, 3, 4, 5. So say C5. Then hydrogen 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Then this one has how many carbon? 1, 2, 3, 4. 4C4. Then hydrogen 1, 2, 3, 4, 5, 6, 7, 8. H8. So now this one has a double bond. It doesn't belong to the same, so it is alone. This one is alone. This one has OH, is also alone. But we have this one. So this one, no. This one, no. We have this one and this one. Now, what to confirm if they belong to the same? Because they seem to look like they have single bonds and they are alkenes. Alkanes, I mean. If the alkanes have got a general formula C, N, H2N plus 2, meaning that if I get 3, I put here, I should come up with this. Let me try C3H 2 times 3 plus 2, C3H 2 times 3, 6 plus 2, 8. Correct. So I've come up with that. So I'll get also this one. If I get C5, I put here. If I'll come up with this one, then they're the same. So let me try C5, then H2 times 5 plus 2. So C5, H2 times 5, which is 10 plus 2, 12. 12. So yeah, they are all using this same one. So they belong to the same homologous series, which is alkanes. So they are using the same. So if the same, which of the following structures belong to the same homologous series of compounds? It is actually 1 and 3. So 1 and 3D. So we go to B8. The structure displayed below is a polymer that was formed from monomer Y. This is a polymer that was formed from monomer Y. So the repeating structure is this guy here. They are saying name the polymer. So the monomer has got how many carbon atoms? 1, 2, 3, 4. So it is butene. The monomer was butene. So the polymer will be polybutene, definitely. So it will be polybutene. Then B, the same. B1, name the monomer Y or butene already. Then they're saying to construct the displayed structural formula of Y. So you just join here. So it will be like this. Let me tell you what it is going to be like. For me, I can just, okay, I wrote this one, which is the same. You count carbon 1, 2, 3, 4, 1, 2, 3, 4. Then you put it like that. So this one and this one is the same, only that they like hiding. So now, so you can write it like this, or from what they already gave, just put a double bond here in Shikwamana. You pick one, we put a double bond. You say C, then you put CH3. Here you put H. Here you put H. Then here you put CH3. That's so. Either this one or this one, they are okay. So this one is similar to this one, but they can only be similar. You just shift this bond. You bring it here. When you shift this bond, you bring it here. Then you will remain with you get this hydrogen, you give it to this one. So when you shift this bond, you bring it where? Here. This bond, you bring it here. You remove this hydrogen, you give it here. So that you have C1, C, and 3 hydrogen there. So you can push this one, bring it down, this one on top. Then that hydrogen you have brought here. Here already, then here, this guy, C3, which is this one, I can bring this guy down, then this hydrogen remaining, and put it on top. Okay, like what I mean is this, to convert this one to this, because I said this and this are the same. You just say, okay, let me just put like, I bring this one here. So C, I got that one. This hydrogen, let me put it down. This one has come down. This bond has come here. That one. Then this one is there. You have seen it, eh? Then this one, double bond, I've brought it here. Then I've removed I've removed this hydrogen. I'll push it here. So I've removed this hydrogen here and brought it where here. So this guy, this has been brought here. This guy will be brought on top here. With this, see, with that hydrogen I brought, gave it, it will be, there were 2, with that one 3. So I brought it, this hydrogen was removed. Then this hydrogen is remaining here. I can put it on top here. Then this one has been put on top, or I can even say I removed this one, gave it here. Then this one, bring it down. C1, 2, 3, bring it down here. C3. Then it has become the same one. So construct the displayed, either this one or this one, just the same. Then we come to C. Monomer Y was reacted with steam under suitable conditions and an organic compound Z was produced. I mean 1, to which homologous series does compound Z belong? So this Y, it is butene. So butene was reacted with steam, which is hydration. So it will become propane, it will become an alcohol. So butene will become an alcohol, which is butane. Okay, so this is an alcohol. I mean alcohol. So now, if they say to which homologous series does compound Z belong, we say alcohol or alkanols. Then they're saying write the general formula of the homologous series stated in C1. Like alcohols, the general formula is just this one. We have already answered it somewhere else. Okay, so this is where we end with this long video. It's quite a long video, as I warned. So for now, we end here. See you in the next video. Bye.